Okay, good. So here we are back again. And as you can see, we're picking up with example 6-9 on page 333 of our textbook in chapter 6, section 2. And as I had left off at the last bit, I wanted to reiterate here that I did something a little bit incorrect. So I was being a little bit too cute, a little bit too sneaky. And here I was applying the trick that right areas are essentially just the opposite of left areas. But then I forgot that fact. So what I looked up in the z table was actually this over here. Remember, because our z table gives us, let's see, you can see it, left areas, right? So here, this area is point zero, point 0.1000, point 1,000. Okay, this is z equals negative 1.28. Okay, so the dead giveaway right here that I was doing it slightly wrong is the minus sign. Does that look right to us? Here's zero. Where's minus? Is it over here? No, no, Grenfell, it's over here. Okay, but what what I actually had right, and I just didn't know it, was the value 1.28 is important, but here we just need to remember that these are left areas, so negative 1.2 all the way over here to 8, that point 1, 1003, that's a left area. And so what we actually want is our left area to be 0.9000. And so when we look up 0.9000 in our z table, where the heck is that? Um, uh, 0.8997. That's, wait, am I thinking of that right? Yeah, that's as close as we can get to 0.900 because that's 15 away, and that's even further lower than 0.9000. Okay, so yeah, that is still our positive 1.28. So as long as we make sure to remember to change that to the opposite, we can just find the right area by looking up the left area and then making sure that we switch to the appropriate z value, okay? The opposite one. So here, in this case, our z value is 1.28, but we're not done yet because it was asking us for what is the cut score, the minimum score to be in the top 10%. Okay, so now we have the z-score, top 10%, but what is the raw test score? The average was 200. The standard deviation was what? 20. I can't read this. All right. So basically, our z-score being 1.28, positive 1.28, means we are positive 1.28 copies of the standard deviation above the average. And that's what it takes to be in the top 10%. We have to have our z-score be at least 1.28 copies of the standard deviation above the average, or higher than that. That would put us anywhere over here, and that's in the top 10%. Okay, but the question now is, after we found the z value, so that was step 2 here. It took me 2 videos to get to step 2. Then step 3 is what? Well, I can cheat and look it up here. Calculate the x value using the formula, and the formula is that. Well, I just cheated. I should have looked it up. I should have written it down as x is equal to, take the average and you add on however many copies of the standard deviation. However many copies, that's our z-score exactly. That's what a z-score is. It's the number of copies of the standard deviation that you're either adding on to or subtracting away from the mean. Okay, And you don't ever have to write a minus because your z-score can be negative. Anything that's below average is going to have a negative z-score. All right, so let's cut the crap. Okay, I just checked with legal and they'll let that one slide. Okay, so here we've got 200 in place of mu. We're going to plug in 1.28. And as I mentioned in the last video, 1.28 is a fairly common z-score that we'll run across from time to time. There are these certain z-scores that are so-called critical ones that we'll run into over and over and over and over and over and over and over again because they correspond to various percentages or percentiles. And so that's why we'll be coming back to them. So if you see these values popping up over and over, you might want to say, oh, hey, let's make a note of that. And next time I'll just remember that it's that. Okay, so enough digression. We've got 200 in place of mu, 1.28 for our z value, and 20 for our standard deviation. And then I have to go and get the calculator. Okay, so here's our calculator, and as you can see here, I've entered in 1.28 times 20 plus 200. Let's go ahead and see what that says. So that says 225.6. And we'll just go ahead and bump that up to 226. Yeah. And being an algebraist, this kills me. Writing equals when I've clearly made an approximation. But for statistics, for our purposes, for having this be usable mathematics instead of algebra, we are going to say, you know what, it's close enough. So that's the value. And here, as long as you can include enough explanation so that, you know, when you're looking at this, you can catch any discrepancies that I've made, you know, then that's fine. As long as I show you what my data was, right? Where I got my z-score, right? Your z-score might be slightly different because you might have used a, you know, a slightly different table. And that's fine, right? So here we're going to call it 226. That's the minimum score we would need to get in order to get in the top 10%. That'll put us at or above the 90th percentile. So the 90th percentile exactly in this case would be 225.6. All right, so that will conclude 6-9 example. All right, so we'll stop here. Only 2 videos.